Okay, good afternoon, class. Right. So today, right, first of all, I would like to say thank you, okay, for being here. All right. So and then before we start our class, so for those who still didn't take the module, okay, that you already paid, okay. So if you can take, I can go to take. Okay, I think the last time I saw the module is at the canteen. Okay, so if you cannot take, then you have to wait until this MCO is over lah, right? Okay, so let's continue, okay, to our discussion, okay. So first we see the the exercise 4.1, okay. So actually this one you already answer, okay, and I just want to discuss the answer, and also after this we will see for paper 3. Okay, for number 18, right? So for thermal equilibrium. So what you have to know about the thermal equilibrium? Okay, so the first one you have to know that the energy is transferred, right, from the hot object to the cold object. Okay, so until both of the object, okay, have the same temperature. So at that moment, we call it has the it already reached a thermal equilibrium. Okay, so let's say if the question asks, what does the meaning by the thermal equilibrium? Okay, so thermal equilibrium, you have to remember three. Okay, there are three sentences. Okay, so the first one should be the temperature of the two objects should be same. Okay, the rate of heat transfer between two objects is same. And another one is the net rate of heat transfer is 0. Okay, so that's the meaning, okay, of the thermal equilibrium. Okay, and then another part, okay, what is the usage of the thermal equilibrium? So it used in the thermometer. So thermometer is used, okay, in use a concept of thermal equilibrium. Okay, so let's say example, if you put your thermometer under your tongue, so means the heat from your body will transfer to the thermometer. Okay, and you know inside the thermometer is the mercury. So the mercury will expand. Okay, then the rate of heat transfer, okay, between the body and also the thermometer is same. Okay, and the temperature of the body and also the thermometer is same, and the rate of heat transfer between the thermometer and also the body is 0. Okay, is 0. So that is about thermal equilibrium. Okay, the process of transfer of heat, okay, until it reach the same temperature. Okay, so that one, after it reach the same temperature, we call it is already reached thermal equilibrium. So let's see for the first question. It says here diagram 18 shows a boy, right, who is having the high fever, right? His mother patches a cold pack on his forehead. Okay, so which of the following statement is correct when the boy and the cold pack are at thermal equilibrium? So you have to find the three sentences that I gave. Okay, so just now the quantity of heat in the boy is same as the cold pack. Okay, and the net rate of heat to flow between the object the boy and the cold pack is 0. Okay, so this is the answer for B. Okay, so for thermal equilibrium, you just need that three sentence. Just remember the three sentence and find the answer. Okay, so number 18, the answer should be B. Okay, for number 17, right, it says here diagram 10 shows a metal container. Water, copper block are in thermal equilibrium. So if thermal equilibrium, the temperature should be same, okay, or equal, okay, to the temperature of the copper block. So the answer is A, right? For the next one, okay, number 17 also, it says here, which of the following statement is correct if there are no heat losses to the surrounding? Okay, so no heat loss means the heat gain is actually equals to the heat loss. Okay, so for this one, the heat loss by the hot water is less or no. Okay, so the answer should be the heat loss by hot water is equal, okay, to the heat gain by the cold water. Okay, so the answer should be C, right? There is no heat loss to the surrounding. All the heat loss is already is received by the cold water. Okay, so that is number 17 is C. Okay, the next one, number 31. So it says here the thermal equilibrium is reached when both of them have the same, okay, temperature. Okay, so number 21 is D. Okay, for the next one, diagram 16 shows an oven is used to bake a cake. So after 40 minutes, the cake reached thermal equilibrium. So when is the thermal equilibrium reached? Okay, so this one should be when the oven has reached, when all the heat has transferred, when the thermometer of the cake is higher, Okay, actually for number 21, this one, okay, I think most of you answered D, right? Okay, but this one actually no answer. Okay, no answer. Teacher, I think we discussed it. Oh, really? Why you didn't tell me earlier?
No, teacher, I was like looking through where was the paper and I see already marked.
Oh my god. I was like, I think this is what I just like no one tell me like, oh maybe I talk about this. Why you didn't tell me earlier? Alright, so so it's okay. We go to 4.2. Alright, so specific heat capacity. Okay. Sorry. Okay. This one is the AC questions, right? So I remember some of you, they don't answer in table, right? The one is the ice cold pack, right? They don't answer in table. So if you don't answer in table, I will not mark your answer. Okay? I want to let you know you must answer in table. Okay? You must put your answer in table. Okay? So let's see for this question. Okay, it says here, so figure A show test tubes, alright, containing aluminium dust and copper dust. Okay, the same mass but having a different specific heat capacity. Right, the both test tubes are heated within the same rate of for a same period of time. Okay, so means the amount of heat supply for both test tube is same. Right, and also the time of heating also same. Okay, so this is actually the temperature before heating and after heating. So this is for the aluminium dust, this is for the copper dust, and this is the specific heat capacity, right? This is for aluminium and this is for copper dust. So what does it mean by specific heat capacity? So the answer is amount of heat, okay, needed, okay, to raise 1 degree Celsius by, 1 degree Celsius of 1 kg of substance. Okay, so you must have the 1 degree Celsius, must have the 1 kg, must have the word amount of heat needed. So this is the keyword. So later if in exam, they will try to find these keywords. Okay, so if there's no these keywords, these 3 keywords, so your answer will be wrong. Okay, so amount of heat needed to raise 1 degree Celsius for 1 kg of substance. Okay, but let's say heat capacity, then you don't need to put 1 kg. Only the say amount of heat needed to raise 1 degree Celsius for the substance. Okay, so that is the specific heat capacity. Alright, for number 2, so this one is the comparison. Okay, so some of you answer in the point form, very good. Okay, so you have to answer in the point form. Okay, compare the temperature rise. So you can see here for the aluminium dust, okay, the temperature rise about 35 degrees Celsius. So this one is 15 degrees Celsius. This one is 35 degrees Celsius, right? So it means the copper dust, right? The temperature increase for the copper dust is higher. So this one you can put, okay, the copper dust has higher increase in temperature. Okay, so that's for number 1. Okay, for number 2, it says here it has to compare the specific heat capacity. So you just see the specific heat capacity. So aluminium dust has higher specific heat capacity. So you just write the answer. Okay, and I noticed some of you, they didn't answer for this question. These 2 questions, the comparison, they didn't give answer. They just answered the relationship one. Okay, so they lost mark for these 2. So you have to see, you have to read carefully. Okay, what is the answer here? Okay, what is the answer? How to compare? So this one, the aluminium dust. Okay, the aluminium dust has higher specific heat capacity. Okay, and the next one is they ask you to relate. Okay, so relate the amount of heat supply with the temperature rise for aluminium and copper dust. So the amount of heat supply is actually same, right? So the amount of heat supply is same, okay, but the temperature rise, the temperature for copper dust, sorry, aluminium dust, oh sorry, copper dust is higher. Okay, this one you should put even the amount of heat supply is same. Okay, copper dust has higher in temperature rise. Okay, so that is to compare the amount of heat and the temperature rise. Okay, and then the next one, the specific heat capacity and the amount of heat required. Okay, so for this one is the higher the specific heat capacity, okay, the higher the amount of heat required, okay, to rise the temperature. So this is another one. The higher the specific heat capacity, the higher amount of heat required to raise the temperature. Okay. Okay, so that's the answer. Alright, so let's see for B. Okay, for B is ask you to explain why the body of a cooking pot is made a good heat conductor, whereas the handle is made of the poor heat conductor. Okay, for this one, you know the good heat conductor means it can absorb heat. Okay, it can absorb heat faster. Okay, and another one, the good heat conductor usually has the low specific heat capacity. Okay, so you can say here, right, a good heat conductor has low specific heat capacity. So, okay, it can heat faster. Okay, so it can heat faster. So this is 2 marks. Okay, low specific capacity 1 mark, so it can heat faster 1 mark. Okay, and then for the poor heat conductor, so poor heat conductor means it has the poor heat conductor has higher specific heat capacity. Okay, so it cannot be heating easily. Okay, or you can say it will take time, okay, for it to be heated, right? So it's same. So 1 mark for the higher specific heat capacity, and another one is for this one, cannot be heating easily. So 4 marks, okay. Alright, so for this one, there's a lot of answer, okay. So I just give in the table, okay. So characteristic, okay, explanation. Okay, some of you put material, right? So some of you said use plastic, okay, use plastic, use polystyrene, okay. Let me remind you, for this question, please don't put the name of the substance. Don't put the name of the substance, because if you put the name of the substance and it's not same like the answer being given, then you are wrong. So you put what is the characteristic. Okay, what's the characteristic of the substance? Why you choose that one? So why you choose plastic? Why you choose polystyrene? Why? What's the reason? Anyone? Why you choose plastic? Why you choose, like, some of you choose polystyrene or any other substance that you use as the container? Don't put the name. Anyone want to try? Yes, poor heat conductor. Okay, you put the characteristic, poor heat conductor. Why is poor heat conductor? So the characteristic is poor heat conductor. So what's the explanation why? So it cannot be heated easily. Okay, or you can say high specific heat capacity, right? So high specific heat capacity. High specific heat capacity. So this one also is same explanation. So it cannot be heated easily. Okay. So another one, did not result. Yes. Okay. So don't put the name. Don't put like you use plastic here. I put plastic here. I put the polystyrene here. Okay. And then you give the explanation. Yes, correct. But they have the specific answer. So if you put wrong material, so your answer will be wrong. So what you want to do is you choose the name. What is the characteristic? Why you choose the plastic? Because you know that is an insulator, good insulator. So you can put here good insulator also. Okay. So for this one, it's actually the answer is more than one. Okay. So good insulator. So the same reason, explanation. High specific capacity, not be heated easily. The temperature will not rise easily. Okay. So that's the answer. For this is the first one. And then the second one, you can say add more ice. Okay. So the temperature will be lowered. Okay. And then some of you say put salt. Okay. Put salt into the ice. Okay. So this one to lower the freezing point. Okay. Then you say the color of the container. So you just put bright color. Okay. The container, okay, bright color. So it will reflect, okay, the heat. Okay. And also it cannot absorb heat easily. Okay. And some of you said put a cover on the top of the container. Okay. So I put this one. Put cover on top of container. This one is to prevent, okay, to prevent heat, right, from enter the container. Okay. So you already got 5 here. So for cover of top also, some of you put the answer, put a plastic, put like a polystyrene on top of it, okay, to close it. Don't put the type of the name of the type of the material, just put the characteristic, why you choose that one. Okay. And bright color, don't need to mention white color, all right, blue light color, no need, just put bright color. Okay, just put a general one, right? So this one you get 10 marks. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and don't be afraid. Like if you lose, let's say your characteristic is wrong, your explanation also will be wrong. No, okay. If let's say your characteristic is wrong, your explanation is right, you still can get marks for it. Okay, so this one 10 marks. So remember, you have to give 5 characteristic and 5 explanation to get 10 marks. Teacher, if I give more than 10, yes, you can give more than 10. Okay, they will not minus your mark. Okay, they say one answer is wrong, they will not minus your mark. They will just take the correct one. Okay, so this is 10 marks. Okay, and please answer in table. Okay. All right, and then for this one, this is for the calculation. Okay, so it asks you to determine the temperature of liquid X. Okay, so this one, remember, you have to use this formula. Oh, sorry, L theta, right? L theta minus L0. Okay, L theta minus L0 divided by L100 minus L0 times 100. Okay, so the question says here, the diagram below shows a thermometer which is not calibrated has a mercury column of length L0 is 5 cm when the temperature is 0 degrees Celsius and L100 is 25 cm when the temperature is 100 and the mercury L theta is 12 cm when you put in the liquid X. So this one you have to determine the temperature of liquid X. So L0 means the length of the mercury when it's 0 degrees Celsius. So when it's 0 degrees Celsius, they already told you is 5 cm. Okay, so I put the info first. Okay, I take out the info first. So 5 cm. And L100 is the length of the mercury when the temperature is 100 degrees Celsius. So there is a 25 cm. Okay, and then L theta is 12 cm. You need to find. Okay, and then another one. Okay, so this one you already got all the info. You can use the formula now. So 12 minus 5, okay, divide by L100 is 25 minus 5 times 100. Okay, so how much you get for this one? 35. Okay, so 35 degrees Celsius. Okay, so that is the answer for 1. Okay, how about 2? So this one you have to change in Kelvin. So if you already learned gas law, right? So how to change from degrees Celsius to Kelvin? You have to add what? 273. Okay, so if you add 273, you will get 308 Kelvin. Okay, so this is for number 2. Okay, 308 Kelvin. Okay, and then for this one, they ask you to find the length of the mercury, okay, if the temperature is 30 degrees Celsius. Okay, so for the question I, this one, I is they ask you to find the temperature when they have the length of the mercury. But for 3, they don't have the length of mercury, but they do have the temperature here. Okay, so you just use the formula same. Okay, so means 30 degrees Celsius is equals to L theta is the one that you need to find, okay, minus L0. So L0 is 5, okay, and L100 is 25, and L theta is 5. Then you have to times with 100, okay. So you will get here 0.3, okay. So L theta minus 5, you got 20 here. Okay, so 20 times 0.3, you got how much? 20 then multiply by 0.3, you got 6, right? So 6, okay, L theta minus 5. So L theta is 6 plus 5. So you will get L theta is 11 cm. So that is the length of the mercury, okay, when the temperature is 30 degrees Celsius. Okay, so that's the answer. Okay, so can you understand for this one? How to calculate the temperature? Okay. Alright, for the last one, E. So this one, they give you the specific heat capacity. So you take out the info that they've been given here. So C is 4,200. The mass of water is 0.8. The initial water is, the initial temperature is 32 degrees. Okay, calculate the heat needed to boil the meat in the water until it reach boiling point. So you have to find the rise in temperature. What is the rise in the temperature? So the final temperature minus the initial temperature. So what is the final temperature here? 100 degrees Celsius, right? It boil until it reach boiling point. So what is the temperature for boiling point? 100 degrees Celsius. So 100 minus 32. So this one you have to calculate the heat energy. So use the formula mc theta. Okay, so the M is 0.8, C is 4,200, theta is 100 minus 32. Okay, so you got the answer 0.8 times 4,200 times 68. So 228480 joule. Okay, remember the heat energy, the unit must be in joule. So that's how you calculate. So this is a very easy one. You just straight away use the formula, but the tricky one is this one. If you don't know the boiling point is 100, you will take 32 then. Okay, so 100 minus 32. Alright, so theta is actually the increase in temperature. Okay, alright, so we finished discuss for 4.2. Okay, now we go for paper 3, right? So I already turn in back to you, okay, your answer. Okay, and I already saw your graph. Okay, so some okay, some not okay. Okay, so never mind. We check one by one. Okay, for your answer. So this is I already prepared the answer. Okay, for you to check. Okay, some of you I noticed, right? When you answer this question, you didn't put the value here. You just put the inside the table because after this you have to tabulate the table, right? So you just put the answer answer there, but this one you leave it empty. So if you put this one, you leave it empty here, there is no marks, okay? So you have to remember, okay, inside in the diagram also you have to fill the value to fill up the answer. Okay, don't leave it empty. Okay, so this one already answer, so you can check. So most of you got it correct. Okay, because the formula is already given here, right? Okay, what's how to find R is 10 multiplied by N. So 10 multiplied by 5. So you got 50. Okay. So let's see for the first one, you have to find the manipulated variable. So how you want to find the manipulated variable? So find in the question. So the first page is already mentioned to you about the manipulated and the responding. So how you want to find? Okay, so underline this word, the relationship between the resistance and the potential difference. So these two, one of it, whether resistance or potential difference is the manipulated variable. Okay, but let's say if you are not sure which one is the manipulated, which one is the responding. So you go back to at your graph here, at your diagram here. So you can see here, okay, you calculate what? You calculate R, isn't it? So this one, if you calculate R means your resistance is the manipulated manipulated variable. Okay, so the resistance should be the manipulated variable. Okay, manipulated variable. So the responding variable is the V. Okay, V is the responding variable. Manipulated is actually N, right? So N is the one that I give you here, N1, N2 here, right? And then if you want to find R, you have to multiply 1 with R here. Sorry. N is 2, 3, 4. So if you want to find, yes, you have to multiply, right? So let's say this is 5, you got 10, 1, 2 times 10, right? So this one, the formula already give to you. 10 times N. So this one should be the resistance. Okay, the V is you have to read from the diagram. Okay, from the voltmeter. So this is the resistance. And for the for the responding is a potential difference. Okay, And for the current and for the constant variable is the current. Some of you put number of dry cells, some put potential difference, some put voltage. Okay, voltage is the potential difference. So if already put the responding is potential difference, so you put the constant variable also voltage. Voltage is also volt. Potential difference also volt. So cannot be the same. Okay. So this one should be current. Alright. So resistance, potential difference and current. This one is actually you already learned. V is equals to IR. Right. The Ohm's law. Okay. For B, this one you already answer. I already said you have to read from the diagram. Okay. And this is the value of R. You can calculate, okay, by using 10 multiplied by N. Okay. And you have to record in the space. So you already see here, you said record the value of R in the spaces provided. So me, you have to put the answer. Okay. Don't forget. And this is the table. Okay. So for the table, it says R and V. So means they have two columns, R, V. And some of you forgot to put the unit. Okay. So must have the symbol and unit. Okay. Symbol and unit. Okay. Must have symbol, must have unit. And also for the decimal point. So for this one, it don't have a problem. All is one decimal point. So 0.0, 0.0, 0.0. So all must be in one decimal point. So let's say if you start here 2 decimal points, so all of it must 2 decimal point. Only the column, not all of it, only a column. So don't put like 10.0 here, it's wrong. Okay, it's by column. So if your column already start 1 decimal point, then all must be 1 decimal point. If your column 2 decimal point, then all must be 2 decimal point. Okay, so that is how you tabulate a data. Okay, so this one, some of you got correct. Okay, but some of you, they missed the unit here. Okay, and the graph. So this is the graph. Okay, so again, mostly of you don't have the unit. Okay, so see mine must have symbol, must have unit, must have symbol, must have unit. Okay, and some of you, their axis, right, is wrong. They put the resistance in the y-axis and the and the responding at the x-axis. So how you want to know whether it's x or y? So I already label here. Okay, it should be y against x. So means V should be y, R should be x. Okay, so don't be confused. So remember, if graph of V against R is y against x. So V is y-axis, R is x-axis. Okay, so don't forget. Okay, and then the axis here, so the scale using, okay, some of you use 1, 2, 3, 4, 5. Okay, some of you use like 2 cm is 10. Okay, so it's okay. You can use only 1, 2, 5, 10. Okay, don't use other scale. No, don't use 4, 8, 16, cannot. Okay, sorry, 12, 16 cannot. Or using 3, 6, 9, 12, 15 cannot. Okay, only 1, 2, 5 or 10. Okay, so let's say in decimal point, 0.1, 0.2, 0.3, 0.4, 0.5 or 0.2, 0.4, 0.6, 0.8, 1.0. Or let's say 0.5, 1.0, 1.5 to 2.5. Okay, if 10, 10, 20, 30, 40, 50, yes. Only this scale. Don't use another scale. Okay, so that's how you use the you draw a graph. Okay, and another one, the next one is the relationship of the graph. So the answer is directly proportional. Okay, so this one is actually easy one because you can pass through all the point. No need to balance the graph. Okay, so don't have a problem. Okay, to find the relationship. Okay, because it's passed through the origin point. So this one is directly proportional. But some of you put the higher the R, the higher the V. No, cannot. That one is the hypothesis. Okay, if you put answer, that one is only valid for paper 2. paper 3 for the graph cannot use the higher, cannot. For the graph, relationship of the graph must be directly proportional, increasing linearly, or inversely proportional. Okay, don't use the word the higher, or the lower, the higher. No, no. Okay, for the graph, only use the relationship of the graph that we learned on chapter 1. Okay, directly proportional, increasing linearly, inversely proportional. Okay, so use that tree. So you have to see what shape, what kind of shape of the graph that you get. Okay. All right, for number 2. Okay, again for this one, some of you put the higher the H, the higher the M. Okay, wrong. Directly proportional. Okay. So for A2, some of you only got 1 mark. Why only 1 mark? Because you didn't show in your graph. What is the value? You read the question carefully. It said show on the graph. So how you want to show on the graph? You have to underline. Right? 0.2, okay, is here, then underline until here. 1 mark. Okay. Then you give me a reading, 1 mark. Okay. So that's how you answer for number 2. So don't forget, if we say show on the graph, mean you have to underline in the graph. Where is the value? Okay. And for number 3, calculate the gradient. Okay. So the gradient again, I told you must have a triangle. How to draw a triangle? So first you decide which point that you want. Okay. What point do you? There's a 2 point you have to decide. So for me, I take the first one here, origin 0, 0. And another one I put here. Okay. I take here. So after that, I put the coordinate. What is the coordinate for this one? 0, 0. And for this one is 7, 0.7, 0.078. Okay. So after you decide what is the point that you want. Okay. There are 2 points. Should be 2 points. Okay. So let's say I take this one and this one. Then I label the coordinate. So after I label the coordinate, I underline until here because I take origin, right? So I underline until here. So you can see I already formed the triangle here. So yeah, this is my triangle. Okay. And another one, let's say, teacher, I don't want to take that one. I want to take from here. Okay. So you read the coordinate here. Right? What is the coordinate? Okay. So for this one, I want to take here. So I already read this one. So this is the 2 point. Then you underline. Underline until there. So you see, this is your triangle. Right? So are you clear how to draw a triangle? Because I see some of you draw like this. Small triangle like that. No, not this one. Okay? You have to draw triangle like this. Decide the 2 points that you want. Okay? And then read the coordinate. Then underline. Okay? So this one, let's say I take this one just now, right? Okay, this one. So this is your triangle if you take this point and this point. But for me, I take this one and this one. So it's easy for you to read. Okay. So my triangle is this one. Okay, but that's still not finished yet. Okay. You have to calculate the size of the triangle, whether it's enough or not. Okay. So the triangle, the size of the triangle, the minimum is 4 times 5 or 5 times 4. Okay. So what does it mean by 4 times 5 and 5 times 4? So this is my triangle, right? So this box here, one box here is actually equal to 1. Okay, so 1. So mine is 1, 2, okay, 3, 4, 5, 6, 7. Okay, 7 times, okay, 1, 2, 3, 4, 5, 6, 7. So, and this is 8, almost 8, right? So, 7. So, this one is already reached the maximum, more than minimum, right? The minimum is 4 times 5 or 5 times 4. Okay, but mine is 7 times 7 is already big enough. So, the size of the triangle is already enough. Okay, so let's say if I took this one, right? So, 1, 2, 3, 4, 5. Okay, so 5 times, okay, 1, 2, 3, 4, 5, 6, almost 6. So 5 times 6. So 5 times 6, is it enough? Yes. Okay, the minimum is 4 times 5 or 5 times 4. You can make it bigger, or you want exactly like the size of this triangle also can. Okay, teacher, I just want like this, also can. But if you want to make it bigger, also can. Okay, so remember how to calculate. Okay, so sorry. Okay, so this one box here, we call it 1. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, and this is 7, and you go up here also 1, 2, 3, 4, 5, 6, 7. Okay, so that's how you calculate your size of triangle. But remember, you have to plot your coordinate. Okay, you have to put the coordinate, okay, on your graph like I did. Okay, and then after that you draw the triangle, then you can calculate the gradient by using the formula. Okay, and some of you, I noticed, forgot to put the unit. Okay, remember I already said gradient must have unit, must have unit. Okay, so what is the unit? The unit must be the y-axis unit divided by the x-axis unit. So what is the y-axis unit? M. What is the x-axis unit? Kg, right? So m over kg. Okay, y-axis unit divided by x-axis unit. So m over kg, or you can say m kg negative 1 also can. Okay, and then one more thing, your answer cannot be in fraction. Don't give me answer in fraction, must be in decimal point. Teacher, how many decimal points should I take? Okay, so the minimum is 2, the maximum you can take 3 or 4. But make sure you round it off. Okay, so this is how you want to calculate the gradient. So later if I give you another one, I don't want you to make the same mistake again. Okay, especially for the triangle. Okay, and also don't forget, it says show on the graph mean you have to do something in the graph. Okay, and all the calculation please put here. Don't put here. Okay, put here. They already give you space, right? So put your calculation here, right? Okay, and then for this one, yes. This is most of you got it wrong. Okay, so it says here the density of the liquid rho is given by the formula rho is equals to m over AH. Okay, so they ask you, it said where A is the cross sectional of the wooden block, which value is 4 times 10 power of negative 3. Okay, 4 times 10 power negative 3. And using the formula and the value in 2A2 means you have to use the formula, the gradient here, right? 2A3. So 2A3, yeah, 2A3. So you have to use the value of the gradient. Okay, so how you can find the density? So you can see the formula here already given like this. Okay, so I will arrange the formula back. Okay. Okay, I will separate it. Okay, one is m over h. Okay, and another one I separate a. Okay, 1 over a. Okay, but when you multiply, you can get back the formula, right? Okay, now you can see m over h. So the gradient is h over m, right? The gradient is h over m. Okay, but in the formula given, m over h. Okay, so how you want to find m over h? So you just put 1 over the gradient value here. So 1 over 0.111. Okay, so 1 over 0.111. Teacher, why? Okay, so why 1 is 1 divided by h over m, right? Okay, so this is actually the origin, y divided by h over m. So if I change the divisions to the multiplication, this one also you have to inverse it, right? So it should be m over h. So that's why I put 1 divided by 0.11. H over m is actually the value of the gradient because your gradient is also h over m. Okay, so you just replace h over m with the value of the gradient, that is 0.11, and the a already given here. Then you use your calculator, you can get the answer 2252.25. Okay, and the unit already given, no need to write it anymore. Okay, so can you clear about this one? Because this one, so many of you got it wrong. Okay, can you understand? Others? Okay, so you know right now. So you can do a correction. Okay, you can do a correction. Alright, so the next one, this one you just substitute the formula. Okay, so you already have the density here. Okay, you use the one that we calculate before, 2252.25. Okay, and then the G. Okay, but this one is actually all in the KSSM, the value of G is 10, but yours is 9.81. Okay, so I put two answer here. Okay, the first one, if they use the G10, your answer should be this one. If you put your answer G is 9.81, so this is the answer. Okay, so this one you just use the formula and you substitute the value. So the density here already calculate. G, okay, G is 10, okay, but I'm using 9.81 because your syllabus is 9.81 and the V already given in the question. So just substitute, you will get the answer 11.05. If you use G10, the answer should be 11.27 Newton. Okay, so don't forget to put the unit. Yes, and for this one, okay, for this one, I already told you, just remember the sentence that I gave. Just remember this one, okay? Make sure your eyes perpendicular with the scale reading of, okay? This one you should see first what is the experiment about. So for question number 2, they use meter, right? So meter means they must use meter ruler, okay? And they use a kg, so mean they must use the electronic balance, okay? So you have to change this one. So let's say make sure your eyes perpendicular with the scale reading of meter ruler, okay, to avoid zero error. Okay, so that the first one if you choose meter ruler. Okay, if you choose electronic balance, though you said make sure your eyes perpendicular with the scale reading of electronic balance to avoid zero error. Okay, so basically what you need to remember, so I will underline for you. This one, make sure your eyes perpendicular with the scale reading of, okay, to avoid zero error. So for this one, you have to fill it based on the experiment. What is the measuring tool that being used? Okay, if they use the, let's say they use degree Celsius, you see the unit for the x-axis is degree Celsius. So you know they use a thermometer. So you change meter ruler to thermometer. So let's say the value of the x-axis is a current, right? So current means must use ammeter. So you change this one to ammeter. Okay, so for this one that I didn't underline, you have to see what is the measuring tool that being given there. So if they say you use the voltmeter, you put voltmeter there. But the sentence must be same. Don't miss any one words. Okay, one word you don't write, then you will lose your mark. Okay, so just put like this one. Okay, because I saw some of you, they put right, but this one they use wrong measuring tool. I don't know why they use a temperature here. Okay, but okay, I already tell you, you have to see what is the axis here. Okay, just see the axis meter, kg. Okay, so that is how you answer for paper 3. Okay, so is there anything you want to ask me for paper 3? Are you clear? So let's say if I give another question, you have to get full mark. Okay, all right. So we still have got like 8 minutes. Okay, so let's see question paper 1, right? Paper 1. The one that I gave to you, paper 1. I still not turn into you, okay? Teacher, avoiding parallax error is right. Wait for a moment. No, avoid parallax error is, okay. Wait. Avoid parallax error. Oh, sorry. This one is not zero error. Parallax error. What I'm thinking. But that one, not zero error. Zero error, you cannot do anything. That one you have to change. You have to change the measuring tool. This one is parallax error. Okay, so makes a correction. Okay. You said just now, avoid parallax error when measuring the height. Your words, Kritiga, your sentence is not complete because you didn't tell what to do to avoid parallax error. Okay, so you have to tell what to do to avoid parallax error. Okay, so if you put like that, avoid parallax error. So how you want to avoid parallax error? So this one you have to make sure your eyes is perpendicular. Okay, so you must have the what to do to avoid, okay, the parallax error. Okay, so your answer is, you need to complete the answer. Okay, another one, if they say they use the experiment is in the light, okay, using the light experiment, okay, so that one you can say the experiment should be conducted in the dark room. Okay, that is the precaution. They say they want two true precaution, and the experiment is about light experiment. So you can put do the experiment, okay, in the dark room. Okay, and if the electricity, okay, for the electricity experiment, you can say make sure the connecting wire is connected tightly. Okay, so if they want two precaution, but usually they only want one only. Okay, so please, okay, do remember this sentence, right? Don't change anything. Okay, so let's see the next one. Okay, for paper 1. I think on desktop, right? Right? Oh, we still have 4.3, right, to discuss. So we discuss 4.3 first. This one. Okay, so 4.3 is actually for specific latent heat. Okay, so specific latent heat, there are two types of specific latent heat: vaporization and also fusion. Okay, fusion is from solid to liquid or liquid to solid. Okay, vaporization is gas to liquid and liquid to gas. Okay, so what is the meaning of the specific latent heat of fusion? Anyone want to try specific latent heat of fusion? Specific latent heat of fusion? Yeah, I know the answer is B. What is the meaning of the specific latent heat of fusion? Can you give me the meaning?
The heat energy absorbed to break the bonds between the molecules to change it from solid to liquid.
Okay, almost correct. You are missing one part. Okay, so what does it mean by specific latent heat of fusion? Okay, so the amount of heat needed, okay, to change, okay, solid to liquid, okay, or vice versa, okay, for 1 kg of substance without change in temperature. So that's the meaning, okay. So you must state what is the phase changing, means from solid to liquid and liquid to solid. And also you must state for 1 kg of substance what is the mass, because this one is a specific, right? So must have 1 kg of substance, and also must put change without change in temperature, or the constant temperature is constant. Okay, so that's one also be acceptable. Okay, so this is the meaning of the specific latent heat of fusion. So must have the word amount of heat needed, change from solid to liquid or vice versa, must have 1 kg, must have without change in temperature. This is the key word. Okay, so this is the meaning of the specific latent heat of fusion. Okay, the one that we can answer just now, you said to break the bond of the molecule, right? Okay, without changing in temperature. That one is they ask you, okay, why does the temperatures does not increase? Okay, so that one you can say the heat energy required to break the bond between the molecule. But in the meaning of the specific latent heat, you don't need to mention about the to break down the molecule bond. Okay, that one if they ask you, okay, why the temperature is not increased. Okay, so this one, okay, so this is the meaning. I hope you can remember this one. Okay, for this one the answer is B, right? Because this one is specific latent heat of fusion. So fusion is solid to liquid. So solid to liquid at this phase. So the answer is B and C. Okay, for number 18, the graph shows the heating curve of the substance at which stage the substance in the liquid and gaseous state at the same time. So this one should be S, T, right? This is gas. Later it will become gas. So the answer is D. Okay. And in a laboratory, water boils at 100 degrees Celsius. So what happened to the boiling point when sugar is added to water? So the boiling point will be increased. Okay. And this one involves the absorption of the latent heat. So mean the heat is absorbed. So the heat is absorbed must be melting and also boiling. Condensation is from the gas to liquid. So the heat will be released to form a bond. Okay, the heat will be absorbed to break the bond. Heat will be released to form a bond. So absorb means you have to you have to absorb the heat, okay, and this one is to break the bond molecule. So of course should be melting and boiling. So the answer is D, donkey. Okay, so I will stop until that first. So to next week on Saturday we will continue discuss, and also for the paper 1. Okay, so thank you class. Teacher, I think we have 4M didn't do 4-3. Oh really? Oh, okay, okay. So I will just give you the question. Okay, maybe you can prepare. Alright? Because yeah. Sorry, I didn't notice. Okay, so I will assign you at GC. Okay? So thank you class. Okay, see you Monday 4K 4S. Right? So bye. Take care. Have a good weekend. Welcome.
Thank you, Cha.
Thank you. Welcome.
Thank you.
Alright, welcome.